The feature of auto deploy has amazing benefits for people who use it. For example, number one, if we take a piece of hardware and we connect it to our network, we can use auto deploy to fully install and customize that ESXi host to be fully functional just by powering it on, going from 0 to hero in just a matter of minutes. And another cool thing about auto deploy is that if we had changes, for example, some software update or a patch or an upgrade, what we could do is associate those changes, those software updates and patches, with the image profile that we're using as part of auto deploy. And then the next time this ESXi host boots up and goes through the auto deploy process, it's now getting the new updated software. Another cool feature that we can leverage are host profiles. Now, we've talked about host profiles in a previous nugget where we had certain settings. We compare the host profile against all of our ESXi hosts, and then we can do remediation to make sure they comply. Well, as part of auto deploy, we can incorporate a host profile with all the settings that we want, and then those settings in the host profile for an ESXi host can be implemented via auto deploy on the ESXi host that's just gone through the auto deploy process. To leverage and use auto deploy, there are several moving parts that you and I want to be familiar with that are going to work in conjunction with each other to make auto deploy work. And one of those is DHCP. So we need a DHCP server, and we have one in our lab environment. It is right here. It's the DHCP server at 192.168.1.100. So when this computer, which will be ESXi4, when it boots up, it has a network adapter that's capable of working in the PXE environment. And PXE is an acronym for the Pre-Boot Execution Environment. Effectively, before the computer has an operating system that's running, there's firmware on the network interface card that is aware of PXE, that is PXE compliant or compatible, and there's a few different flavors of PXE. But the long and short of it is that the network card itself, as part of knowing how to work with PXE, is able to do things like a DHCP discover message. So in DHCP, there's 4 packets basically. There's the discover, which goes from the device looking for an IP address. There's the offer, which is sent from the DHCP server, and then the client requests that IP address that was offered, and then the server follows up with an acknowledgement. So this one and this one are from the client to the server, and the offer and the acknowledgement are from the server to the client. To take advantage of auto deploy, we need to supply a couple of additional options inside of the offer that's coming from the DHCP server, specifically option 66 and option 67. Option 67 provides a name of a file, and specifically that's an NBP. And that acronym stands for a Network Bootstrap Program. So it's a teeny little piece of executable software that this device that's doing the PXE boot can go ahead and load and process and continue following the instructions provided by this little boot program. And one of the challenges is that this device is booting up, if you provide it the name of a file, the Network Bootstrap Program, and in a VMware environment, it's going to be one specific for VMware. It needs to know where to go ahead and get that from. So option 66 is going to be the name or IP address of the server. Specifically the IP or name of the TFTP server, that's the home to that file. So with that information provided in the options from the DHCP server to this DHCP client, so after the DHCP process completes, and this device knows of the IP address of the TFTP server and the name of the file, this device, which we're going to go ahead and call ESXi4, because it's not ESXi4 yet, but it will be once the auto deploy process is complete. So what this host does, ESXi4, it would then go ahead and initiate a TFTP connection over to the IP address of the TFTP server, and the ESXi host will load that Network Bootstrap program that it downloaded from the TFTP server. It'll also process a little configuration file that it also downloaded from that TFTP server. So using both the configuration file and the Bootstrap program that it downloaded from the TFTP server, it runs that, and part of the instructions are to go out and initiate an HTTPS-based boot request over to the auto deploy server. Our auto deploy server is going to be our vCenter server appliance that has been enabled for auto deploy. So as that ESXi host makes that boot request to the vCenter server appliance, the auto deploy feature has to make some decisions. For example, we could have several image profiles that have different versions of the ESXi software, as well as various add-ins. Maybe we have a special driver for the storage provider or some other software that's part of a provided vSphere installation bundle, a VIB. And the vCenter server appliance needs to know which image profile to use before it just streams one down to the ESXi host so it can go ahead and load from it. In addition, the vCenter Server appliance could have multiple host profiles. And in the host profiles, it's settings regarding ESXi hosts. So the question is, how does the vCenter Server appliance decide which image profile and which host profile it should go ahead and stream down to the ESXi host who's doing the auto deploy boot? And the answer is rules. We have rules that are set up. So as part of that request that ESXi4 is making to boot from the deployment server, the Network Bootstrap program provided information to that server as well, with things like the BIOS information, UID, host name, and other details that the auto deploy service can use as part of the rules to make a decision on which image profile or which host profile it should go ahead and stream down to the ESXi host. So as the deployment service goes through the rules, if it finds a match, it says, great, you matched this rule. I'm going to go ahead and based on that rule that you matched, I'm going to give you this image profile and this host profile, and that information is streamed down to ESXi4, who is now booting off that image and applying the host profile settings. And as part of the rules being matched, once that ESXi host is up and running, that host will show up in our vSphere web client in exactly the location where we told it to go. Maybe we have a special container for it, like a folder, or maybe we want to drop it right into a cluster. That's all configured as part of our rules. Now, in the early days of auto deploy, we didn't have all the tools that are available today here with version 6.5. For example, regarding image profiles, VMware makes it really easy to work with image profiles. They give us a beautiful option right inside the vSphere web client using a tool called Image Builder. And as part of that functionality with Image Builder, we can create our own software depots if we want and have various images that we might want to use. And if there's updates and patches, we can include those as well. And we can build all of those using the Image Builder feature. I'll give you a tour of that when we do the demonstration. And then for host profiles, we already had a nugget on host profiles. And so you'd follow the same process we did there for taking an existing ESXi host, creating a new host profile based on that, and then just going through the details of that to either remove the parts that you don't want to be part of that host profile or modifying properties and then associating that host profile as part of our rules for auto deploy. One other mystery that I'd like to share with you as well is, where do we get the Network Bootstrap program, the specific one for vSphere, that we can place on our TFTP server? And the answer for that is simple. We'd go in the vSphere web client, we'd select our vCenter server, click on the Configure tab, and there's an option under Auto Deploy to download those files, which are going to include multiple Network Bootstrap program files and also a configuration file called tramp. And that tramp configuration file allows the ESXi host that's booting to know who the auto deploy server is. And in our case, our auto deploy server is our vCenter server appliance, which is at the address of .111 on the 192.168.1 network. Now, also for convenience in the lab, what I also did is I'm also doubling up, and because our vCenter server appliance is running a specialized version of Linux called Photon, it actually supports TFTP. Now, in a production environment, you'd want to use another TFTP server on your network, but for the lab, for convenience, we could use the TFTP server function built into the vCenter server appliance, and that would be perfectly fine as well. So when this is all functional, the ESXi host, or the ESXi host to be, is going to boot up. It's going to have a PXE compliant network adapter. It does the DHCP process with the DHCP server. It learns of the boot server, the TFTP server, and the Network Bootstrap program, which we've placed on that TFTP server. In our case, that's going to be coming from the TFTP service on our vCenter server appliance. Once the ESXi host downloads that via TFTP and runs that Network Bootstrap program and also processes the configuration file, it then knows to initiate a boot request over to the auto deploy server. In this case, that's going to be our vCenter server appliance with the auto deploy service at .111. Based on the rules on that vCenter server appliance, it's going to know which image profile and which host profile, if any, it's going to go ahead and stream down to that ESXi host, at which point this ESXi host boots from that streamed download image that's being sent from the auto deploy server, and with the host profile configurations applied, becomes a citizen of our vSphere environment. I also want to point out that to make life easier, the vCenter server appliance and the auto deploy feature, once an ESXi host is checked in, the rules have been set up, if this ESXi host later reboots, because the vCenter server appliance already knows about that host, it's already run the rules, it won't bother running the rules again. It can simply stream down the appropriate image and host profiles so that ESXi host can boot again. And when the ESXi host is doing this auto deploy in this fashion, it's not storing anything to its local drive regarding the image. That's referred to as a stateless auto deploy configuration. There's also an option for stateful. And with the stateful option, the ESXi host is actually storing the files on a local disk. And so for subsequent reboots, it wouldn't have to go back through the auto deploy feature. It would have the files locally on a local hard drive. And there's also an option for stateless caching. And with stateless caching, it's very similar to stateless except for the fact that if in a subsequent reboot, the auto deploy server is not reachable for some reason, it keeps a cached image locally that it can refer to in the event the auto deploy server is not reachable. So in this nugget, I wanted to chat with you about the concepts and a lot of the moving parts that make up auto deploy. And in the next nugget, what we'll do together is we'll walk through step by step the implementation and verification of auto deploy in our hands-on lab. So I'll see you in the next video. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.